Rational functions. In this section, we're going to be looking at rational functions, and we're going to be finding what we call their asymptotes, and then we're going to be graphing rational functions. So the definition of a rational function is a function whose rule is a quotient of polynomials. And right here, I have an example of what a rational function looks like. So here, these three examples, you could have y equals 2 over x. Notice that y equals 2 over x, that's that inverse variation form that we covered in the last section. We also might see something like y equals 3 over 4 minus 2x, or y equals 1 over x squared. So these are all working with the rule quotient, meaning dividing. Quotient means dividing of polynomials. Another thing you're going to maybe recognize in this section is discontinuous functions. And that's when irrational functions are discontinuous, which means their graphs contain one or more jumps, breaks, or holes. So if we look at this graph down here at the bottom, there is a break between these two graphs right there at y. Notice there's no graphs that are taking place at 0 here on the y-axis. So that's where you would have discontinuous happening, where there's a break or a hole. And then asymptotes, like I've talked about, that's a place on a graph where a rational function is discontinuous, and it's at the asymptotes. And there are specific values that we're going to find, and we're going to get into some of those examples here coming up. This is where the line gets closer and closer to an absolute value, but never touches. So it's going to get close and close and close. So notice these two graphs get close and close to 0, but they're never going to touch. So that's, we're going to find that's working with asymptotes. So this example here is of a discontinuous function with your asymptotes right here. So we've worked with lots of different functions, and this chart is showing linear functions and their equation, y equals mx plus b. We've worked with, let me go back here, linear function remembers our straight lines, working with slope and the y-intercept. We've worked with quadratic functions in the form of ax squared plus bx plus c, where we're looking at how far the graphs translate up and down vertically, finding the axis of symmetry. So remember, quadratic functions are like a U or an upside down U. We've worked with square root functions where we're working with the radical sign here. So y equals the square root of x minus a plus b. And we've talked about whether the graphs are translating horizontally or vertically. So they're kind of like a curve, like half of a curve right here. And then what we're working with here in chapter 12 is rational functions, and that's in the form of y equals a over x minus b plus c. And notice what the graphs look like with that. So this function here, y equals a over x minus b plus c, that formula is really going to help us work with finding asymptotes that we're going to look at here coming up in the next few slides. So let's first try an example here. They want us to identify the excluded value for each rational function. So here for a, we have y equals 4 over x minus 1. The first thing we need to do in order to find the excluded value for the rational functions is to set our denominator equal to 0. So the denominator is our bottom value, that x minus 1, and we're going to set that equal to 0 and solve for x. So we set it up as x minus 1 equals 0, and what I'm going to do is I'm going to add 1 to both sides. So I'm going to end up with x equals 1, so the excluded value is 1. So that's for A. For B here, we have y equals negative 5 over x plus 4. Again, we're going to set the denominator equal to 0. Our denominator value is x plus 4. This negative here out in front, that can be paired with the 5, or it could be paired with that negative x plus 4. but we can connect it with the numerator there. So what I'm going to do is I'm going to solve for x. So I have x plus 4 equals 0. I will subtract 4 to both sides. So I end up with x equals negative 4. And so my excluded value is negative 4. So when you have questions like this doing the bookwork, you just are looking at the denominator values, setting it equal to 0, and solving for x. Here we're getting into the asymptotes like I talked about in the first few slides, and this is where that break takes place. There are specific values where the break or jump is happening within a rational function, and we need to find those specific x, y jump values where the graphs are going to jump. So we need to use that formula that we saw previously of y equals a over x minus b plus c to help us find the asymptotes of finding x and finding y. A rational function in the form of y equals a over x minus b plus c, we have what's called the vertical asymptote that excludes the value, or x equals b. And we have the horizontal asymptote, which is y equals c. So we have horizontal and vertical asymptotes. Vertical, x is going to be equal your b. Your horizontal, your y, is going to equal your c. So an example here is if we have y equals 2 over x, if we have this rational function, how would we find our asymptotes? Well, for a vertical asymptote, what we're going to do is we're going to set our denominator equal to 0. So x minus 0 equals 0. So x is just going to equal 0. And then for my horizontal asymptote, we're looking at our c value, which is this value right here. And what is that value? It's 0. So y equals 0. Here we have y equals 1 over x plus 2 plus 4. How do I go about finding my vertical asymptote? Well, I set this x plus 2 equal to 0. And I solve for x to get x equals negative 2. And then how would I find my horizontal asymptote? Well, it's that c value. My c value here is 4, so it's going to be y equals 4. So let's do this example of identifying my asymptotes for this example. So we have y equals 1 over 4x plus 16 plus 5. The first thing we're going to do is we're going to identify our vertical asymptote, so finding what x equals. So what we have to do is we have to set our denominator equal to 0 and find the excluded value. So what I'm going to do is do 4x plus 16 equals 0. I'm first going to subtract 16 to both sides to get 4x equals negative 16. And then I'm going to divide 4 to both sides to get 4 equals negative 4. So my x is going to be negative 4. That's my vertical asymptote. Now I need to find my horizontal asymptote. So y is going to equal c. Remember, c is out here. It's plus or minus a value. So my c is going to be 5. So my horizontal asymptote is just going to be y equals 5. And that's my answer. Again, here's the form to help you solve. So we solved for our vertical, which is here. Here we have our horizontal. So our final answer, vertical asymptotes, x equals negative 4, and our horizontal asymptote is y equals 5. Let's do another example working with asymptotes. So we have y equals 3 over x plus 77 minus 15. So let's find our vertical asymptote. So we're going to look at our denominator and set this equal to 0. So we have x plus 77 equals 0. I'm going to subtract 77 to both sides. So x equals negative 77. That's my vertical asymptote. Then we find our horizontal. So we're going to look at that C value. So what is my C value here? This minus 15 is my C value. So y is going to equal negative 15. So my final answer for the second example is going to be my vertical asymptote is negative 77, and my horizontal asymptote is y equals negative 15. So when you graph these radical functions, the jump is going to take place where x is at negative 77 and y is at negative 15. Now what we're going to do for our last example here is they want us to graph this function. So let's walk through the steps. So we have y equals 2 over x minus 3. So our first step is we have to identify the vertical and the horizontal asymptotes. So my vertical asymptote is going to be this x minus 3. And we're going to set that equal to 0. So it's going to equal 3. Why is it saying b equals 3? Well, because part of the rational function form is y equals 1 over x minus b. When you're finding your vertical asymptote, it's this b value right here. So for here it would be 3. So b is 3, which technically is x equals 3. So that's our vertical. Then we're going to find our horizontal asymptote. So we're going to look at our c value. Now here we don't have a c value. So my horizontal asymptote is just going to be 0. So y equals 0. They want us to then graph the asymptotes using a dashed line, and I'm going to show you that here in the fourth step, but you would graph the asymptotes with the dashed line. I'll show you that here coming up. But let's go into step 3. We're going to make a table of values. We're going to choose some x values on both sides of the vertical asymptote. So we're going to choose x values that are on both sides of 3. So some negative values and some positive values. So here we have x is 0, 1, 2. Notice we did not include 3 because 3 is my vertical asymptote. So I did 1, 2, 4, 5, and 6. And then what I did to get my y's is I plugged in these x values into the equation here to find my y. So at 0, it's negative 2/3. 1, it's negative 1, 2, negative 2, 4 is 2, 5 is 1, and 6 is 2/3. Again, we did not put 3 because that's part of my vertical asymptote. So once I create that table, then I'm going to plot these points and connect them to create my curves. Notice that the curves are going to get very close to my asymptotes, but they're never going to touch them. Whoops. So it's going to get very close to 3 and 0, but it's never going to touch. So when I graph this, this is what my graph is going to look like. Notice if I go x equals 3x to 3, 1, 2, 3, I have this green dash line. That's my vertical asymptote. And if I go to y at 0, that's going to be my horizontal asymptote. So right here at this point, the graphs are going to get very close to the asymptotes, but never touch it. And notice you can see that with the curves and how they're graphed and how they get very close, but they never are going to touch. So in this section, you really need to know how to find your asymptotes. And then if they give you a rational function, you need to know how to graph it by finding your asymptotes, creating a table, graphing your asymptotes, and then graphing the graph altogether in general.